So welcome to all of you. So today we will see the application of logic to switching circuit. So switching circuit, switching means switch, right? Circuit, you know the circuit in the physics. So what is that? Suppose we have this battery, so battery there. Okay. Now, suppose the bulb is bulb is, we join the bulb is here somewhere. The bulb will be here. Now here what, to switch on or off, we have to take a switch here now. We have to take a switch. We will call this as S. Right? If switch on, then it will what? Switch is on, then bulb will be glow now. Right? So if switch is off, then bulb do not glow. So off means 0. Off means the switch is off. We'll take this as 0 or this as a false now. Right? So now if the switch is on, we'll take this as 1. That means this as a T now. Now see, if you put 0 and T, see for P and Q suppose, right? This is what T F, right? T T F F, and this is what T F T F. How will you use the 0 and 1 here? Okay. So now instead of this, what P Q, this is what 1 1 0 1 0 1 0. Okay. P and Q. P and Q. So you have to take the product now. P and Q means what? This is the product. This is 1. 1 into 0 is 0. 0 into 1 is 0. 0 into 0 is 0. Right? So now see, T and T is T. T and F is F. F and T is F. F and F is F. C is T. Right? For R, P or Q. So for R, you have to take the sum now. Right? So 1 or 1 is 1. Right? 1 or 0 is 1. 0 or 1 is 1. 0 or 0 is 3, right? So for R means what? You have to take the sum, right? So R means sum. Take the better one actually, right? The same thing here. Now, suppose we have given like this circuit like this. Suppose the switch, we are not lighting the battery and the bulb now here. So just we are writing this. Your circuit is suppose like this. So there are many switch. We have a parallel switch, right? Then this is what? Like this. Okay, so like this. So here what, the battery is here somewhere. We will only show the battery now here. We are not showing the bulb now. Okay, or you may say this is what your bulb, this is your battery, like this. Okay, now if three switches are parallel, if now here what, two switches are in series. These are in series, right? So what to do now? How to find the statement for the circuit now, right? That we are interested. Okay, so we'll take the next one. Application actually. This is your battery, this is your L means bulb. This is your switch is S1, this is S2, right? Then the logical statement for this one is what? S and S2, right? S1 and S2, right? Now suppose this is the logical statement for this one. Now suppose these are series now. We'll take the parallel now. Okay. So for parallel. This is your battery. This is your bulb. This is your circuit. Now this is your S1. This is your S2. Then this will what? S1 or S2. Now switches are either parallel or series. Okay. Now this is your logical statement for this circuit. This is logical statement for this circuit, right? So we'll see the output for this one. So same thing here. What output? Same thing now. Here what? Suppose now this is series now. Okay, so this is in series, right? So that means what? This is S1, this is S2. So true or false, we will use true or false. T T F F. True means what? The switch is on, and F means what? The switch is off now. So ST will be what? T F T F. Now these are in series now. See the output of this one now. So S1 and S2. So T and T is T now. See, that means what? Both the switches are on. If the both switches are on, the current will be passing through this switch. That means bulb will be on now. Right? Bulb will be glow. That means this is true. Now one of the switch is the, this is what? Switch T is on and this is off. Now see, the current will not pass through. So that means circuit will not be completed. So it will be false. The output will be, bulb will not glow now. That means this is false. Now see, this is off now here. The current will be stopped here then. It will not pass it through. That means circuit again will not be completed. And both the switches are off. That means current will not, that means will not pass through this to this to this also. That means what? Circuit will not be completed. So this is the false, right? Bulb will not be. That means what? If the switch, this is what the position of the switches, on or off. Your T is what? On, and your off is F is means the switch is off now, right? So what about the series now? So these are in series. Series means we have to take the and suppose these are parallel now. Suppose the switches are parallel. You may write this word, switches are parallel. Now see here. What happened here? S1 or S2 now. Now both the switches are on. Both the switches are on. There is no problem. The current will be passing through here or current will be passing through here and the circuit will be completed. Now one of T is on, but this your what? S2 will be off now. This will be off. So suppose this is your S2, this is your S1. Now S1 is on now. So then the current will be like this. Then this will what? Now here what? The pass will do. The circuit will be completed. That is this one T. Now your this switch is off now, but this is on now. This switch is off and this is on now. Then the current will be what? Passing through like this. This is switch on. This is what? Now see the circuit will be completed. Right? If the circuit completed, then the bulb will be glow now. So this will be T. Now the both switches are off now. The current, suppose this is what here, but this switch is off. Suppose this is what? The switch is off. So bulb will not glow now. Right? So it will be F now. Right? This is the output of the circuit. This is the output of the circuit. Okay? So now we'll so that means what? If two switches are in series, then connect their tag by AND. If they are parallel, then connect the two switches are by OR now, right? And the same thing for the truth table now, right? Okay, so express, we'll take the problem. Express the following circuit, circuit, okay. Circuit in the symbolic form, and write the input and output, input output means truth table, input output table. Okay, now the circuit is given like this. So no problem for Venn diagram like this. Always this is what passing through this one. Okay, now this is what S1, this is S2, this is S1 dash, this is S2 dash. S2 dash means negative. This is negation. Okay, so we have to write, express the circuit in the symbolic form. Okay, solution. The symbolic form of the given circuit is, now see, all these three are parallel. This is parallel to this one. So S1 is parallel to S2. Each parallel to, now these two are in series. So that means what? S1 complement, S2 complement, right? Complement negation. This is your symbolic form. Now what you have to do? You have to write input output table. Okay. So we write input output table. The input output table is as follows. Okay, so write S1, S2, S1 dash you want, S2 dash also you want. Okay, S1 means what? T, T, F, F, T, F, T, F. So you have what? F, F, T, T, F, T, F, T. Now see what you want. Okay, so first we will find S1 complement intersection, that means S2, and S1 complement, that means negation of S1, and S2, negation of S2 actually. Okay, so you may write to this is negation of S1 and negation of S2 also. Okay, so or you may keep this as it is, no problem. This is what actually negation of S1. So what they want actually, so yes, they want negation S2. This is what? This is equivalent to what? S1 or S2 or negation of S1 and negation of S2. Doesn't matter this. Okay, this is logically equivalent to. Yes, this is logically equivalent to this. Okay, now we'll write this is what? S1 negation of S1. This is what we'll write, negation of S1, negation of S2. So negation of this one, negation of this one. Write this is what? F and F is F. F and T is F. T and F is F. T and T is T now. Okay. Now we'll find S1 or S2 also. S1 or S2. Then we'll connect this by R also. T or T is T. T or F is T. F or T is T. F or F is F. Then S1 or S2 or negation of S1 and negation of S2. So this. So F and T is T. F and T is F and R. This is R. F or T is T. T or F is F or T is T. F or T is T. This is T. That means what? Your bulb will be glow. Always glow. No matter whatever the position of the switches are. This is what T. That means what? Here bulb will glow. Right? In any stage now. No, it will not depend on the position of the switches S1, S2. Right? So that means here what? If S1 is on, then S2, S1 complement. That means negation of S2 will be off now. Right? Here what? That means what? Bulb always glow. Right? Whatever the truth values of the switches, this is not important here. Okay? So bulb is always glow now here. Next. Question is same now. You have to express this in symbolic form. We have to express this in symbolic form. Okay. So my drawing is not so good. Just I am trying this. So what we want? This is your S1. This is your S2. This is S1 prime. This is S2 prime. This is your S3. Okay, so we write in symbolic form. Okay, so what we have to do actually, okay, so here let P S1 is switch on, S1 is switch on means close, and Q S2 is switch close. Q is what? S2 is switch close. Okay, so what is the symbolic form? The symbolic form of the given circuit is, okay, so this is P, so you may write P what? The switch S1, you may simply write this what? S1, P is what? The switch S1, Q is what? The switch S2. Instead of this close, you don't write this what? Close, or this is off, something like this, right? So we'll write just simply what? P switch S1 S2. Okay, now then the symbolic form. Okay, so now these two are in series. So that means what? P and Q. These are two in parallel. That means this is parallel, right? So this is what? Negation P and negation Q, and all these are in series with S3. So your S3, you have to write R. R is what? Switch S3, and this will be in series. That means this is R, right? So this will be your symbolic representation of the circuit, right? So just we have check once again. These two are series. Yes, these two are series. These two are series. Yes, these two are series. And these two are parallel. Yes, these two are parallel. And all this is series with these two, right? That means we are correct. Now you have to make a table now. You have to make a table. So you have to draw the table now. So this is what? P, Q, R. Right? Then you want negation P. So there are three letters are there. That means you have to use 3 letters. That means 2 raised to 8. 2 raised to 3. That is 8. So 8 rows should be there. So that means what here? T, 4T, 4F. 4F. Oh, I have to write this somewhere now. So I write here now. Okay. So P and Q are negation P and negation Q. Just I am writing this here now because I want this space. Okay. Okay. So we have to take the attention for this one now. Okay. We have to make a truth table for this one. Just we have to prepare a truth table now. Now 2T, 2F, 2T, 2F, then alternating, take care, alternate TF, 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 then negation, that means 4F, 4T. Now negation Q means 2F, 2T, and 2T means 2 times first 2 times F, then 2 times T, 2 times F. Okay, now we'll take one by one. We'll do this one, we'll do this one, and then we'll connect this by this one. Right? So we are writing this is what P and Q. Then negation P and negation Q. I'll say this is what 1, 2, 3, 4, 5. I will say this is 6, this is 7. Then I will do this is 6, this is 7. Then what? 6 or 7. This will be your 8. Then I will connect this 8 with your row number is 3. So and 3 or 3 and 3 and okay. We will write 3 and 8 or 8 and 3, doesn't matter. Both are the same. This is your final truth table. Okay. So we can give the number. Huh? Okay. So we do this. P and Q now. T and T is T. T and T is T. T and F is F. T and F is F. F and T is T. F and T is T. F and F is F. F and F is F. Now negation P and negation Q. Negation P and negation Q. F and F is F. F and F is F. F and T is F. F and T is F. T and F is F. T and F is F. T and T is T. T and T is T. Now 6 or 7. That means you have to take this. Right? T or F is, so take the 2 fingers on this. T or F is T. T or F is T. F or F is F. F or F is F. T or F is T. T or F is T. F or T is T. F or T is T now. Now 3 and 8. 3 is 8. Right? And 8. Now this. T and T is T. F and T is F. T and F is F. F and F is F. Then T and T is T. F and T is T. T and T is T. Okay? F and T is F. Right? Now see where we make a mistake, we have to take the care. So this R, this is AND. Okay. So instead of writing actually, so now we'll check the ones again now. P and Q. Okay. So P and Q. So T and T is T. Okay. T and T is T. T and F is F. This is correct. F and T is F. F and T is T. Oh, here we make mistake here. What? F and T is F now. This should be F. F and T is also here what? F. See, you have to take the care. F. F. Okay. Now this is correct. Now negation P and this. What? F and F is F. F and F is F. F and T is F. F and T is F. T and F. So F. T and T is T. T and T. This is correct. Okay. Now 6 or 7 now. T or F is T. T or F is T. F or F is F. F or F is F. F or F is now here F. F. F or F is here also F. So take the care. F or T is T now. F or T is T. This is correct. Now 3 and 8 now. So 3 and 8. T and T is T. F and T is F. F and F is F now. Yes, it is F. F and F is F. Okay. So T and F is F now. This should be F. Okay. So F and F is F. This should be also F. So now T and T is T and F. Now this is correct now. So T F, okay. So T, okay. Now this is correct. You may write T as 1 and F as 0. In the next time we'll write T as 1 and this word, so that it will be very easy now. Okay. So in the next table we'll write T as 0 or T as 1 and F as 0. Right. It is better to write this word for switching and circuit 1 0. Right, 1 0 0 1, right? We'll write in the next. So it is better to write this. Okay, now same question. Second. Okay, so we'll take this one. So this is what S1, this is S2, again S2 is here, then this will be S3, this will be S1 prime. Okay. Okay, this is your circuit. So we'll write this is how many switches are there? 3. That means PQ are there, right? Okay, so P switch S1, S2, R, S3. Okay. Okay. The symbolic form of the given circuit is. Okay. So what is this? This is P R Q. Okay, P R Q. Then this is series. This will be S2. That means this will be your what? Q. Right? Then again it will be in series. Write in bracket. S3 is R. In series, they are parallel now. These two switches are parallel. Okay. So now this will be negation of P now. Negation of P. Right? This is your symbolic form. Now we don't want this figure now. Okay, so just I will write this here. P R Q and Q and R negation P. Okay, again there are 3 letters in the truth tables. What we'll do? This is P Q R. We'll write 1 1 now. 1 1 1 1 0 0 0 0. Note that for and we'll take the multiplication, and for or we'll take the sum now, right? So that it will be easy now. And 1 plus 1 is 1 now. So this is what 1 1 0 0 1 0 1 1 0 0. Then alternate 1 0 1 0 1 0 1 0 1 0. Okay. So for switching and circuit, instead of using T and F, just use 1 and 0. Okay. So okay, now we'll do this one. So you want somewhere negation P, we'll write negation P. So this is what 0 0 0 0 1 1 1 1. Okay. Now we'll take one by one now. P R Q. P R Q. So we'll give the number 1 2 3 4 5. So we may write this one and this is what first we'll do this one, then we'll do this, we'll connect with this one because and is there. Okay? No problem for that. Okay, now R means what? You have to take the sum, right? Okay, now P R Q is 1 plus 1 is 1 now. 1 plus 1 is 1. 1 plus 0 is 1. Then 1 plus 0 is 1. 1 plus 0. 0 plus 1 is 1. 0 plus 1 is 1. 0 plus 0 is 0. 0 plus 0 is 0. Okay. Now 5. Now this is you. 5 and q now. 5 and q. So this is your 5 and take the product of this one. 1 into 1 is 1. 1 into 1 is 1. 1 into 0 is 0. 1 into 0 is 0. 1 into 1 is 1. 1 into 1 is 1. 0 into 0 is 0. Then 0 into 0 is 0. Okay. This is your 6. This is your 6 now. That means up to this we did this. Up to this we did. We'll write now this what? R negation P. R. Where is R? R is here. Where is negation P is here. And you have to take the R. That means take the sum. Okay. 1 plus 0 is 1. 0 plus 0 is 0. 1 plus 0 is 1. 0 plus 0 is 0. 1 plus 1 is 1. 0 plus 1 is 1. 1 plus 1 is 1. 1 plus 1 is 1. And 1 plus 0. Yes, 0 plus 1 is 1 again. Okay, this is your 7. And then what? You have to take this 6 and 7. This will be your last column. This will be your 8. Last column. So, and is there. 1 into 1 is 1. 1 into 0 is 0. 0, 0, 0, 1, 1, 0, 0. Yeah, very simple now, right? So 1 and 0 is very easy, right? So easily you can do this one. Okay. Yes. Now we are correct. Okay. I hope that you understand this one. Okay. Now see what we have given. We have given the circuit. What we did? What we did here. So we find this is what the symbolic representation. Now we have given the symbolic representation, and with the help of the symbolic representation, we have to draw the circuit now. So how we will draw the circuit? With the help of the symbolic representation, right? So we take the problem. What? Construct switching circuit of the following. P or negation P and Q or negation P, negation Q and R or negation P. Okay, solution. Now this is what? This is the symbolic representation you have given. You have to draw the circuit now. Okay, so let P for switch S1, Q for switch S2 and R for switch S3. Okay, so we draw now. First with this bracket. Now see, these two are parallel. R is there. That means these two are parallel. So we'll draw this one first one, and then what? So in the lower part we have to draw this one. So first in the upper part we'll write this. What? PR. Again this is parallel. P means what? This is your S1. S1 is parallel with this one. So now these two are in series, right? So this is what? S1 prime now, right? And Q. So this is your Q means S2, right? This is your first part. Okay, first bracket now. S2. Again, this structure is parallel to this one. This structure is parallel to this one. For this one. Again, these two are parallel. Okay, so we'll write this one. So what is this? Negation Q. negation Q and R in series now. So there are again two switches now here. There are two switches. We will write this. First we will complete and then we will write this. Okay. Now negation. Okay, we will give the name. Yeah, negation Q means what? S2 prime. This will be your S3. This will be your S3. They are in series. R. That means these two are parallel. Negation P. Negation P. This is your S1 dash now. Right? So now this is your battery. This is your bulb. Okay. Now this direction. Okay. So this is your structure. Okay. So you may join this what? You may join like this. Doesn't matter. That means what? You may like this. This is your main structure. You may join like this also for better diagram. This is here for better diagram. Okay, you may draw this like this. But now see that is also the same now. Okay, so now see these two structures are parallel. These two are parallel. For this one, check again. This is what? These two must be parallel. See, these two are parallel. Now here what? This is single one. Now these two are series. These two are same. Yes, we are correct. Right? Okay. We take the next problem. They don't want the input output. Or you can do for the problem for exercise. Find a input output also. Okay. Now P and Q and R P R Q and negation R. Okay, solution. Let P for switch S1, Q for switch S2, S3 is there, R is also there, right? R for switch S3. Okay. Now we'll draw the circuit now. Okay, we don't want this, so we'll draw it. Okay, now this is R. This is R. That means first we'll do this one. This is what? And R, everywhere and is there. So that means what? This, right? So P and Q and R. That means this is your S1, this is your S2, this is your S3. Now this is parallel. This is parallel to this one. Again these two are parallel. Right? Again this will be divided into here now. Again it is divided. So P. Now this is your S1. This is your S1. Okay. Okay. So now this is parallel. Again Q and R in series. Q is Q for S2 and this is negation R, that means S3 prime. Right? This is your structure and this you have to join with your battery. This is your bulb. You will give the direction like this. Right? So go. Okay, so I hope that you understand this one. Okay, now we'll take one more problem on this. The main thing is very important now. So now see there are many switches are this. So you have to form a circuit, simplest circuit. Again we'll take one more problem and then we'll take the next problem. So this is what next type of the problem after this. So negation R or negation P and negation R. Okay. Now this is your symbolic representation, and you have to draw the circuit diagram for this symbolic representation. We'll say let the same figure switch S1, S1, Q for switch S2, R is there, yes, R for switch S3. Okay. Okay. Now see, there is R, right? These two structures are parallel. Okay, now first we will draw this bracket. Now this is AND is there. Okay, so R is there now. Again, these two are parallel. So what is this then? Okay, is it correct? We will check. Yes, P and R. Yes, so P and R. That means they are in series. Okay, so they are in series. Okay, so this is P and R. So P for S1 and R for S3. Now this is R is there. That means this structure is parallel to this structure. So parallel. So now this AND is here. That means they are in series. No problem. So just we'll do the number later on. Okay. So negation Q. That means this is S2 dash. Negation R means S3 dash. Okay. So this is the square bracket. Now again this whole structure is parallel to this structure. So we draw this structure first. It is in series. So there are two switches. Just we'll draw these two switches. Is what? Negation P means S1 and negation R means S3 dash. S3 dash. Okay. So we may write this is what this. Okay. Now this is your battery, this is your bulb, this is your circuit. Now see these two circuits R is there. That means what you may write draw this doesn't matter. Right? R is there. No? I hope that you understand this one. So now we'll stop here.